In this video we shall talk about denormalization. By definition, denormalization is something reverse to normalization. It is a process of storing the join of higher normal form relations as a base relation which is in a lower normal form. So why do we need denormalization? First, to increase data access speed, because such queries as join or queries with some aggregation functions like, for instance, AVG, minimum or maximum and so on may be slow enough. But the result of that operations that is stored in some denormalized relation will be accessed quickly. The second idea is to simplify queries, because of course join queries or some other queries may be rather complex, but once again, when we use denormalization, we achieve a result of something simple and easy to access with simplified queries. And as long as we no longer have a lot of normalized relations, and instead we have something denormalized like 1-2 relations instead of several. This allows us to avoid some non-necessary schema complexity. We can achieve denormalization through several techniques. First, we can use joining several relations into one. This idea was just reviewed. We have a lot of normalized relations and we are somehow joining them into lower quantity of denormalized relations. The next two approaches are rather similar except for one little difference. So, we may use caching or aggregation relations and or attributes. What's the difference? When we are using caching something, we get new relation, new data here, and there is a possibility to extract the data into its initial form. With aggregation, we also have some new form, and there is no way to extract the data in its initial form. So that's the only difference, but the similarity is in both cases we have some new form of storing some data. And of course we may use materialized views if our DBMS has that capability, and the idea here is that we create some SQL query, we put a name to that SQL query, and the result of executing that SQL query is stored in a temporary table, and then DBMS uses that table to increase data access speed. Now we shall review several examples, starting with joining. Imagine that we have to achieve zero delay for accessing a lot of phone numbers in a lot of departments. This is our initial schema. Of course, we may use join operation here to access all that data, but that will take a lot of time. Or we may join, in quotation marks, this data initially and store it in the following way. So here the query will be executed quickly, easily, and we'll get that information almost instantly. Or we may achieve the same goal, solve the same task with caching. This is the initial situation, this is the final situation. So you see that both relations are here, but here in this relation we have that caching attribute. And we gather all that information into this caching attribute using something like, for instance, triggers or something like that, and that information will be instantly accessible for any query to this relation. The next approach is aggregating data. Imagine we have achieved once again zero delay for accessing data about quantity of employees, their children, their cars, and something like that. We may use several methods. Method 1. If we have few of data to aggregate, we have only 3 parameters like employees, their children, and cars, and nothing more. We may use this approach when each parameter becomes a column of a table. The table should always have one row only. And this is the aggregated, pre-calculated data that is stored in such aggregating relation. Method 2 is useful if we have a lot of parameters. We may use 2 columns with name and the value, and this table will always have two columns only, but it will have as many rows as many parameters we have. So this is the name of the parameter, this is the value. And the most interesting approach, using materialized views. This is how it may look like in Microsoft SQL Server. This is the initial query. Of course, we may execute it as is, but then we creating a view, it has to be naming this query, this is the name. And then we create clustered index on the result of this query, and that forces the DBMS to store the data in some temporary table. And then we may write down such a query as select all from, use that name, and the DBMS will instantly select all that data and return that data to us. And also the DBMS will update this table on predefined algorithm. For real, denormalization is rarely mentioned by its name, but the idea here is the next. When we are using normalization process, we have to think, should we do the following step, getting the database in more normalized situation? Maybe we should or maybe we should not. Once we decide not to do this step and stop here, this is a kind of denormalization in quotation marks. Or maybe we've already made that step and we do not like the situation, so we may return back and get something similar to the initial situation. Maybe the same like the initial situation, maybe nearly the same, but we get the less normalized form than we have here. And that's the denormalization also. In the next video we shall discuss normalization step by step, and we shall see where to stop in order not to be forced to use denormalization.